Hello, in this video I'm going to introduce you to logarithms, so I'm going to cover what they are, how to switch between logarithmic and exponential form, and just some basic rules to do with them. I'll timestamp the different parts of the video below so you can kind of skip through to whichever part you want to see, and if it is useful go over to my channel where I have loads of other maths tutorials. Okay, so to introduce us to the idea of logarithms, we're going to look at 4 different questions. Okay, so here they are. And the first one is pretty straightforward. We've got 10 to the power of x equals 1000. And you don't need to know any knowledge about logarithms to solve this. You can probably do it immediately, and you'd know that it's 10 cubed, isn't it? So let's write that down. 10 cubed is 1000. Okay, let's look at example 2. We've got 3 to the power of y is 27. Well, you could probably think about it and say, oh, well, it's not squared. Oh, it's 3 cubed as well. So actually we've solved the second one. And currently we don't actually need to know anything about logarithms or stuff like that. We can solve these just by looking at them. However, when it gets to question 3, we've got 4 to the power of z is 16,384. And that's a bit trickier to solve. I mean, initially I don't know what z could be. I could chuck in a few different values of z in my calculator and I would probably get the answer eventually, just through trial and improvement. But if we move on to question 4, I mean, that's even trickier. We've got 10 to the power of p equals this number here. Again, I'm going to have to maybe do some trial and improvement and hope I can get in on, close in on an answer, but that's not too easy to do. And this is particularly where logarithms can be useful for us when we're solving an equation with an unknown in the power. Okay, and so to introduce logarithms, we're just going to go back a step to question 1 and 2. And I'm going to take this thing here, this 10 cubed equals 1000, and I'm going to rewrite it in an equivalent equation what I'm going to call logarithmic form, because it's using a logarithm. So I'll write it out and then we'll talk about what it means. So we'd write it like this: log base 10 of 1000 equals 3. Okay, so this little number here, this little 10, we call the base of our logarithm. Okay, and these two equations are equivalent. Okay, they're saying the same thing. All this one on the right is saying is 10 to the power of 3 equals 1000, which is exactly the same as this one here. Okay, and that's what logarithms are saying. So let's now do the same thing, but for question 2. So we would say it's log base 3 of 27 equals 3, because, well, 3 to the power of 3 does equal 27, and that's all the logarithm is saying. And the reason this is useful is because let's write this equation here from question 3. Let's write it in a logarithmic form. So it would be log base 4 of 16,384 equals z. Okay. And initially you might be thinking, well, that's not particularly useful because now I just know z is equal to this thing here. But actually you'll have a button on your calculator that I'll put up on the screen now. And that button on your calculator will enable you to calculate this. And I'm going to type that in now. So I'm going to type in log base 4 of 16,384. Okay, and that tells me that z is equal to 7. And so we've answered the question using logarithms. Let's do the same thing now, but for question 4. So 10 to the power of p is 125 point whatever. Okay, let's write it in logarithmic form. So it's log base 10 of, and I'm going to copy and paste this to save me a bit of time. So let's put that over there. There we go. And that is going to be equal to p. So again, let me chuck that in my calculator. So log base 10 of 125.8925412. And that tells me that p is equal to 2.1. So it's actually quite a nice answer. And we've solved it using logarithms. So logarithms made these questions a lot easier for us to solve. And we'll be able to solve a lot more equations using logarithms too. Now, let's look at a more sort of generic case. So here we go. Log base a of b equals c. Let's write this in an exponential form. All this statement is saying is a to the power of c equals b. Okay, these two things are equivalent. One is in what we'd call a logarithmic form, so this one here. One is in an exponential form, which is this one here. Okay, but they say the same thing. That's all they're saying. Now, there are some constraints, so by that I just mean some rules on the value of a that we can have with our logarithm. Okay, so on the base. and we'll talk about why. So the base a for logarithms has to be greater than 0. Okay. Now the reason for that is, let me write out an equation and we'll see what's wrong with it. Let me say log base -2 of x equals 1/2. Okay, so that seems perhaps okay at the minute, but let's now try and solve this equation. Well, remember, all this equation says is -2 to the power of 1/2 equals x. So let me write that down. -2 to the power of 1/2 equals x. And remembering our index laws, -2 to the power of 1/2 is the square root of -2 equals x. And now we're dealing with complex numbers, which we don't really want to do. So to avoid that from happening, we say a has to be greater than 0. So that's one thing we need to make sure we're aware of. The second is that a can't equal 1. Okay, so a has to be greater than 0 and a can't equal 1. And let's think of an example as to why that can't be. Let's say log base 1 of 6 equals x. Well, what is this saying? It's saying 1 to the power of x equals 6. Well, 1 to the power of any number is just 1. So, there's no solution that I can find that's going to solve that equation. So we say, okay, a has to either be greater than 0, that's fine, and it also can't equal 1. As a result of this, okay, we get that our value of b must be greater than 0 too. And in the next video, when we look at exponential graphs, we'll see why, but more sort of generally, we could say, okay, we've got some positive number a raised to the power of another number c, whatever that is. Well, could that ever be less than 0? Well, no, it couldn't. No matter what power you raise a positive number to, it's always going to result in another positive number. You can't get to 0. You can tend towards 0, but you're never going to get to 0, and you can't get negative either. Okay, and if you're unsure on that, I'll leave a link to the next video on exponential graphs that will hopefully explain that in a bit more detail. Okay, so that's some sort of generalizing what we've just looked at in terms of logarithms. So let's look at a couple of questions where we're switching between logarithmic and exponential form, and this is going to sort of show us an important rule as well. So you can see here we've got the following equations in exponential form. Let's write them in a logarithmic form. So the first one, 2 cubed is 8. Well, that means that log base 2 of 8 is going to equal 3. Okay, so the first one's pretty straightforward. The next one, we've got 7 to the power 0 is 1, so I could say, okay, log base 7 of 1 is going to equal 0. And this is going to give us an important kind of result that we can have that's going to help us out. And that is, if you've got a logarithm, say to a generic base a, and the argument, so the number in the brackets, is 1, this will always equal 0, because what this is saying is a to the power of 0 equals 1. And this is true. Any value a that we put to the power of 0, that's always going to give us an answer of 1. The next couple, we're going to look at going from logarithmic form to exponential form. So the first one, it's kind of an equation to solve. We could say, well, okay, x cubed is going to be equal to 27. And cube rooting both sides, we get a solution of x equals 3. So that's pretty straightforward. The next one, log base 10 of 10 equals 1. One thing we haven't mentioned is that sometimes you'll see this written like this, log of 10 equals 1. Now, I suppose it's because log base 10 is a popular base to use. When you're using a logarithm with base 10, sometimes you just don't write it because I guess it's written that much, it saves a bit of time. And so if you ever see something like this here, just log of 10, you can assume it's to a base 10. Okay. So let's now sort of solve this or write it in an exponential form. That would be 10 to the power of 1 is 10. Okay, and this again gives us kind of a generic result, which is that if I have a logarithm, say to a base a, and then my argument is a, that's always going to give me an answer of 1, because obviously a to the power of 1 is equal to a itself. Okay, so finally we're going to take a look at something called the cancellation principles, and this comes from the fact that taking a logarithm just reverses the process of raising something to a power. Okay, and so a logarithmic function and an exponential function are inverses of each other, which is something we'll talk a bit more about later on. Okay, but let's look at this idea. So here we've got log base 2 of 2 to the power of 4 equals x, and we're asked to find what x is. Well, let's write this in exponential form, and we get 2 to the power of x equals 2 to the power of 4, and so it follows that x must be equal to 4. Okay, and another way to look at this is by saying, well, all this says is 2 to the power of what gives me an answer of 2 to the power of 4. Well, the answer's got to be 4. Okay, and from this we get this first cancellation principle, which says that if we have a logarithm base a of, say, a to the power of x, this just equals x. Okay, and you can hopefully see that from that example. Let's take a look at another one. So here we've got 2 to the power of log base 2 of 4 equals x, and again we're asked to find x. So I'm going to focus first on the power, and I'm going to write it over on the side, and I'm going to say it's log base 2 of 4. Okay, what does that equal? Well, that's saying 2 to the power of what gives me an answer of 4. Well, it's got to be 2 to the power of 2. And so now I know, well, log base 2 of 4 is equal to 2, so let's replace that up here, and we get that, well, 2 squared equals x, and so 4 must equal x. And so we can see the argument of this logarithm has just come down to the base. Another way to think about this might be to say, well, okay, 2 to the power of, well, what is this saying? It's saying 2 to the power of what gives me an answer of 4. Well, that answer you are then putting to the power of 2. So it kind of has to follow that that equals 4. Okay, and we can generalize this idea like so. We can say if we've got, say, a number a to the power of log base a of x, this equals x. And if you want perhaps another way to think about this, we could say, okay, we don't know what this is, so let me write it next to it. Let's say log base a of x equals some number b. Let's write this in exponential form, and we get a to the power of b equals x. Well, let's look back at what we started. A has been raised to log base a of x. Well, log base a of x is b. So this thing here just says a to the power of b, which we know must equal x. Okay, and it kind of follows from there. So hopefully this video has been useful. If it has, please do go to my channel where there are loads of other maths tutorials, and thanks for watching.